Again, let's use the pen. So here we have a shape. Okay, let's have this shape. Okay. So for the shape, we can fill here the area. So first of all, here, if you want to make a color here, okay. So generally, if you want to make a color, we are coloring the interior shape. So if you have a shape like this, so it's very easy to find the interior shape. If you have a shape like this one, so in that case, for this shape or for this area, we have to know if it is interior or exterior. For this area here, we have to know if it is interior or exterior. So we'll see some rules that help us to decide if the area is it interior or exterior. Let's suppose that we have this shape, and within this shape we have another shape. Now this shape here should be, let's suppose that I want to fill with the color. This shape should be filled or not. So it depends. If it is interior area, it will be filled. If it is an exterior area, it will not be filled. So we have to decide if this shape that we have here is it interior or exterior. So this is what we will see at the first part. And then if I want to fill the shape, if we have any shape. So I've said that we can fill the shape with color. We can fill shape with gradient. We see what that's mean. Gradient here, we are using two colors, and we can make a gradient, for example, from the red to the green. Okay, so we can make a gradient of color, or I can use a texture. What is the texture? So it is an image, and you are repeating this image as a texture. So you see that the shape it is filled by this texture. Okay, and also for let's suppose that you have this shape, for example. Now for the border of the shape, we can make it a border like this, or we can make it as a continuous line like this. You can use dashed line like this. You can use, for example, here dash dot dash dot dash dot, etc. So here I can define how I make the border of the shape. So we can do this by using the stroke. So in today's class, we'll see how to use the stroke and what are the different types of stroke and how to program the stroke, how to change the dimension of the stroke. Okay, how to change the type of the stroke and how to change how to change the dash line type. So this is what we see in today's class. So here, first of all, we study the interior filling methods. We see two techniques to define the interior and the exterior region. We study also the transparency, and we'll see also how to create color. We will see here how to fine-tune the border properties of the object. And here we are talking about the stroke. And then we will see how to make complex border and interior properties. Now let's start here for the interior and exterior area. So let's suppose that you have this shape that you have here. So you can see that this part here, this area is an interior. This area here is interior. What about this area? Is it interior or exterior? So here it depends on the technique that you use. Or if I return back to the previous example here. Now this area, is it interior or exterior? So if I fill now this shape, the inner rectangle here will be filled or not. So it depends. If it is interior shape, it will be filled. If it is exterior shape, it will not be filled. So here we'll use two techniques or two rules to define that if a region is it interior or exterior. So the first one, it is called the odd or the even odd rule. The second one, it is called the non-zero rule. So it is the even odd rule. Here, the region is interior if the number of crossing is odd, and exterior if the number of crossing is even. So here I want to study an area. For example, I want to check if this area is it interior or exterior. So I can make a point here. I can make a line in any direction towards infinity. Okay, and then I have to check the number of crossings. So here to go from this point to outside, you have one crossing here and another crossing here. So the number of crossing here is 2. يعني even. if it is even, it is an exterior area. If I fill this rectangle, if I fill the outer rectangle, the inner rectangle will not be filled. Now let's use the second technique. So the second technique is the non-zero rule. Okay, so here we have to select direction. So here we start. Let's suppose what we'll start with this point. So I have to select the direction, starting from this point to this point, and we can select here another point. So we have to use the same direction. You can use any direction, okay? But here, for every line, you have here direction. Now, I want to check this area. You can make a point here and go in any direction. Make a line like this, okay? And here, for the non-zero rule, so the region is interior if the signed crossing number is not 0. So here we'll use the rule for the non-zero winding rule. So the non-zero winding rule means that you have to determine whether a given point falls within an enclosed curve or not. So unlike similar even odd rule, it relies on knowing the direction of the stroke for each part of the curve. So before using the non-zero winding rule, here we have to know what is the direction of the stroke. Okay. Now, for a given curve C and a given point P, so how we have to use the non-zero winding rule? We have to construct a ray heading out from the point P to any direction toward infinity. So if we turn back here, our point P here, we can draw a line to outside. So it can be here, it can be a line like this, it can be a line like this, it can be here, it can be here, it doesn't matter. Okay, you have to start from the point and you have to go outside. Towards infinity, right? Outside. And then we have to follow all the intersection. We have to find all the intersection of C with this ray or with this line. And then we have to calculate the score. So how to calculate the score? So for every clockwise intersection, clockwise in this direction, okay? And here we are talking about, so let's suppose that we have a line like this, and we have an intersection with a line going like this. So here, if we scroll it here, the clockwise intersection. In that case, we can subtract one. So here you can subtract or add one. So here you have to create a rule. Okay, so you can take here in this example, clockwise intersection, you can make -1. And anti-clockwise, you can here add 1. If you have an anti-clockwise, let's use the highlighter. If you have an anti-clockwise intersection, you have to make here +1. Okay, so these are the guiding rules. You can use here +1 and here -1. It doesn't matter. Okay, and then here, according to the number of crosses, you have to make +1, +1, -1, +1, -1, and then you have to search for the total. Now, if the total is 0, that means the area is exterior area. If the total is not 0, that means it is an interior. So if the total winding number is 0, then P is outside. Outside, exterior area. Otherwise, if you find the total which is 2 or 1 or -2, -5, any value that is not 0, that means it is an interior area. So here we have an example like this for this shape. Okay, and here we are studying this area in both techniques. Okay, so here in the first technique we are using the even odd, and in the second technique we are using the 0. Okay, now by using the even odd case, so in the even odd case, so let's suppose that we want to study this area. Okay, so you can make a point and you can go to any direction. You can go to this direction, for example. Now, how many crossings do we have? We have 1 and we have 2 crossings. So the number of crossings is even. So if it is even, exterior area. You can see that here it is not filled because it is an exterior area. You can select a point like this. Okay, you can go outside. You have 1 intersection here, 1 intersection here. So the number of intersection is 2. Okay, so here 2 is even. That means it is an exterior area. You are just to avoid passing the intersection like this. You are not allowed to do Yes. You can go in any direction, you will find the same result. So you have two intersections, so it is even, and it is exterior. Now, if you use the non-zero winding rule, now to use the non-zero winding rule, first of all, you have to know the orientation or the direction of the stroke. So let's suppose that we start from here, we have to make the direction. So this is the line, you have another line, going like this. And then we have to return back to the same point. And you can see that here we have these directions. We need these directions. Okay. Now, let's suppose that we want to study this area. So we can make a line like this. Okay, and let's suppose that clockwise we make +1 and anti-clockwise we make -1. Okay, so we start from this point. Here we have an intersection. It is clockwise or anti-clockwise with this line. So you can see that it is clockwise. Okay, so here we have, let's calculate the number. Let's calculate 10. So here we have 1. And then let's go, we have another intersection here, and it is also clockwise. Because the line is going like this, so it is clockwise. So 1 + 1 equals to 2. 2 not equals to 0. That means it is an anterior area. So if n equals to 0 means have exterior area. If n not equals to 0, interior area, I mean, if I fill this shape, the part that you have here will be shaped, will be filled. Okay, if we take a point here from here, so I want to know if this area is it interior or exterior. So you can select the point, and then you can go outside. You have one intersection here, and you have seen that clockwise +1, anti-clockwise -1. So our number here is +1 is 1. So 1 not equal to 0. That means is exterior or interior not equal to 0. Yalla, try to participate. This is very, very important. You have to understand this. So I repeat, if the number equals to 0, yani exterior. If the number n not equals to 0, yani interior. So in this example, n is 1. 1 not equals to 0, that means it is interior. That's why you can say that it is filled. Can make another example. So here, let's check this area. Okay, so the area that we have here. Let's use for the moment the even odds rule. Okay, so you can select any point, you can go outside, you have one intersection. So one intersection is odd, that means it is interior. Now let's select this area here and make like this line. So I have one intersection, I have two intersections, 2 is even, that means it is exterior area. So here the area that you have here will be exterior. So if I fill this shape, if you suppose that this is a polygon, or if you suppose that this is a general path, if I fill this general path, this area will not be filled. We can take this direction, you will find the same result. I have one intersection, two intersections, so the number here is even, and it is in exterior. Now let's check this area that you have here. Okay, so you can make a line like the line that you have here. Okay, so I have one intersection, two intersections, so the number of intersections is even. If the number is even, and it is in exterior. Okay, same thing. If you make a line like this, same thing. If you make a line like this, you will find the same result. Always two intersections, that means it is even, yani exterior. Now let's use the non-zero winding with it. So here we are using this technique clockwise, x1, and anti-clockwise, -1. Okay, so let's start with this area. So it is interior, but let's check. So we can make a line. So you can see, first of all, you have to make the directions. So we can start from here, continue here, continue. You have to return back to the first. Okay. Now we start from this point. Here we have an intersection, and you can see that it is clockwise intersection, but it's in this direction. So here we have +1. So our number of the total equals +1. So 1 is not equal to 0. That means it is empty. Now, if we check this area, so I can start from this area and make a line like this. Okay, so this intersection here, you can see that it is clockwise. Okay, so here we have +1. So our n equals to 1. And then let's continue. Here we have an intersection also. It is clockwise. Okay, so we have two intersections. We have 1 plus 1. So our n equals to 2, not equals to 0. That means we have an interior. Okay, now let's check this area here. Now, the first intersection here, you can see that it is anti-clockwise from the bottom to the top. So here, let's make it clockwise +1, anti-clockwise -1. So the first one here is anti-clockwise. So our n here equals to -1 because it is anti-clockwise. And then let's continue. Here we have another intersection, but this intersection is clockwise. So I have to make +1. -1 plus 1 equals to 0. If the total equals to 0, that means the area is exterior. Any question about this? This is very, very important. So in the exam, they can give you a graph like this, and you have to define or to give the answer if the area or the different or the selected area are they interior or exterior. So here we selected the point here, and we selected this direction. So it's better to select the direction like this. So here we have just one crossing. One crossing, we have +1. +1, and it's not 0, so it is empty. But even if you select a line like this, okay, so you have here one crossing here anti-clockwise, then here we have clockwise intersection, and also have clockwise intersection. So we will have -1. So our number equals to -1 plus 1 plus 1. So here the total will be 1. 1 not equal to 0. That means here the area is inferior. Okay, so here we have an example. Start here from the general part. So here we have two general parts, and we try to plot or to fill the two general paths by using the two techniques. Okay, so here we have the first general path. Okay, and in the first general path here we will use the wind or wind even odd. So here we are talking about the winding. We are using here the even odd winding. So general path if there's a new general path, and here you can make dot, and then you can make the winding that you want to use. Now, if you want, after creating the general path, if you want to draw the general path, you can draw it. But if you want to fill the general path, in that case, you can select what is the rule that you have to use. You can use the even odd rule or the non-zero, okay? Now, let's start here by making this general path. Okay, so in the first general path here, we have 5 points. Okay, so you can see that here we have 5 points. Now, how to get the coordinate of this point? So you can see that this point belongs to a circle. Okay, so if you select here, suppose that the angle here is 0, so you can find here the coordinate of this point. Now, if we want the coordinate of the second point here, so what is the angle here? So the total angle from here to here is 2 pi. And we are dividing this circle by 5. So the angle that you have here between 2 points is pi, or 2 pi over 5. So the angle here is 2 pi over 5. The angle for this point here is 2 pi over 5 multiplied by 2. And for this one, well, 2 pi divided by 5, but multiplied by 3, etc. Okay, so for every point, you can use this technique, and here you have, if we suppose that you have this angle here, which is 2 pi over 5. Now, how can we get the coordinate of this point here? So here we can use the sine and the cosine. So if we draw the x and y coordinate, so if you have this angle, so this value that we have here, which is the y, it is the sine. So here we have the sine of the angle. And if we need the x component, so the x component is the side that is here, which is the cosine. That's why here, to find the coordinate of the point, what are we using? So for the point x1, we have here, we are taking the cosine of 2 pi multiplied by 5. And then here we are using the scale of 100 to make it, because if you use this technique, it would be a circle with a radius of 1. Now we need a radius of 100, so I have to multiply this value by 100. So the first point here, x1 and y1, will be the points for the angle 2 pi over 5. Now the x coordinate will be the cosine of 2 pi over 5 multiplied by the radius, and the y component will be the sine of 2 pi over 5 multiplied by the radius. So I have to do this for the next point. Okay, so we can suppose that the first point here at the coordinate 100, 0. This is the second point. The next point here, instead of using 2 pi over 5, we can multiply this quantity by 2. So it is 2 pi over 5 multiplied by 2. Okay, so it is 4 multiplied by pi over 5. And for the next point, you have to multiply 2 pi over 5 by 3. So it will be 6 pi over 5. And for the last point, it will be 2 pi over 5 multiplied by 4, meaning you have 8 pi over 5. So this is for getting the coordinate of the different points. Okay, then we have to make the path. We have to move to x2, y2 will move to the point 2. Okay, and then we make a line to the point 0, and then we make a line to the point 3, then we make a line to the point 1, and then a line to the point 4, and then we are closing the path. So this will be as this shape. So we start from the first point, okay, and then we are making here all these lines. This is for the points, okay? Now, if we draw this, you will find this shape, okay? But if you feel this shape, okay, so if you feel the shape, this area is interior, 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 interior. But what about this area? So this area depends on the rule that you want to use. Okay, so if you use the even odd winding rule, you will find that this area is exterior. It's not here filled. Okay, if you use the next winding rule, so you can see that the area here is interior, interior, and it will be filled also with the color. A question about this? Okay, now let's check our code. So here we have done the point, we have the coordinate of the point, and then we've created the path, and then we are going to the point 120, and we are drawing the path. So with this, we will give us the first shape, which is this shape. Okay, now, if you want to make the filling, if I need the second shape, so how to do it? So we selected already what is the technique that we are using on the rule. So here we are using the even odd winding group. Okay, now let's go to, we have to translate over the x-axis with 200 point, and then we are filling the path. So we are filling the path here with the even odd group, and you will find the second shape that we. Okay, now if I want to change the rule, so we can change the rule here by using here the set winding rule. So path dot set winding rule, and here we have general path dot, instead of using the first path, which is even odd, now we can use the non-zero rule. So here we have wind non-zero. We are making translation of 200 over the x-axis, and then we are filling the path again. So this will give us the third shape. So in the first shape, we are just drawing. In the second shape, we are filling by using here the even odd rule. And in the third shape here, we are filling by using the non-zero winding. Okay. Now we have another shape now. So this is another general path. Now we create a new path. Okay. So I have moved to x0, line 2. So here we are going to the point 0, then we have line 2 to point 1, line 2 to point 2, line 2 to point 3, line 2.4, and then we are closing the path. And we are moving again to the point 0, and we are making here a quadratic curve. Now, plot 2 to point 4. So the point 4 here will be the control point, and we are going to the point 1 by using here the control point, which is the control, which is the point 4. And then also I'm making another curve from the point 1 to the point 3 by using now the point 2 as control point. So you can see that we have a different point, but here we are adding two quadratic curves. And also we are adding also two cubic curves. The first cubic curve will be to the point 2 by using the two control point, point 1 and point 3. And then we have another cubic curve going to the point 4 by using that now the two control point, point 1 and point 3. So at the end, what do we have? This is the pen. At the end, you can see that we joined the different points. And we added now a quadratic curve here, we added a quadratic curve here, and we added cubic curve here, and we added cubic curve. Okay, and then here was the instruction to draw the shape. So you can see that here we have draw path, and this is, so here you can see that we went minus 400 for the x and plus 220 for the y component. So this will select this area, and then we draw shape. Now let's suppose that I want to fill this shape. So what is the winding rule that we use? Okay, so here we have to select the winding rule. So here we didn't select any winding rule. Okay, let's select, for example, now for the path, let's select now the, or let's start with even odd. Now we are setting the winding rule to 0. Let's see what now even parts. And let's translate due to the translate. Let's make 200 over the x and 0 over the y. And now let's fill the path. So g2.fill, and we want to fill our path. Now we'll get the second. So initially you can see that we don't have the filling, but let's now make the filling. Now we are filling the shape, and this is the output of the filling of the shape if you are using the even odd group. Now if you want to check the non-zero winding group, so we can make another translate. Translate. Now let's make 200 over the x-axis and 0 over the y-axis. Now let's change the winding rule. Now let's make the winding rule as non-zero. So you have the non-zero winding rule. You can translate again. $200 over the x component and 0 for the y. And now I can fill again the path. So G2 will fill the path. Now we see the filling of the curves. So wind limit non-zero. Limit. So now you can see that you have the filling here by using the non-zero winding rule. This is the non-zero winding rule for the both. But here we have the even odd winding rule for the two paths. Any question about this? Okay, let's continue. Now we have seen that if you want to fill, we can select color. Okay, we have seen that here I can change the color. So how can we change the color? We can use G2.set color. And then we can select any color. For example, color.red. So here the red is already defined. Okay, so you can see that now we have the filling by using the red color. Okay, I can also define the color by giving the red, green, and blue components. Okay, so here in human eye, we can see the light starting from wavelength from 300 nanometer to 800 nanometer. So 300 to 400, so here we are talking about the violet. And 800 here, it is called red. Okay, so after the red, greater than the red, you see the infrared. And before 300 nanometers, so here we have the ultraviolet, the UV. So we have the infrared. So we have the UV light, then we have the visible area, and then we have the infrared. So this is if we are talking about the length of the, so here we are talking about the wavelength. We are talking about frequency, we have the infrared, then the visible area, and then you have the UV. Okay. Now, from theoretical point of view, the color is defined by the distribution of the intensities over the visible spectrum of the light. So now we can say only this area, which is from 300 nanometer till 800 nanometer. You have 300, 400 nanometer, and the maximum will be 800 nanometer. If we have a wavelength that is greater than 800, we cannot see it. It will be the ultraviolet. If we have a wavelength that is less than 300 nanometer, we cannot see it. It will be the UV light. Okay, so our eye, the human eye, has three sensitive or three receptors or three sensors to detect. So here our eye can detect the green. So we have here green receptor. We can have the red receptor and we can have the blue receptor. We have three receptors: red, green, and blue receptors. And generally, the blue receptor, they are less sensitive than the other. So this is for the person. For the animals, we can have animals with only one receptor or two receptors. We can have animals having more than 6 receptors. We can have animals like the shrimp, for example, they have 7 receptors. So they can see 7 receptors, and we can see more color than us. Okay? For the cat or for the dog, I think for the goat, it has 2 receptors only. So for the persons, for the humans, we have 3 receptors. We can see red, green, and blue. Okay, and for every color, we can talk about the hue, the saturation, and the. So what is the hue? So the hue corresponding to the dominant wavelength of the product. And here we are selecting one wavelength, and we are selecting one color. And the saturation is the purity of this color. So the purity in which high when the spectrum consists of a narrow peak. So you are talking about the spectrum. The spectrum is narrow like this. So narrow. So you are talking about the saturation. And then you have the intensity here, which is the lightness of the color. So if you have light color, if you have high intensity, that means you have high energy for this frequency. Now, our screen here has some LEDs. So for every pixel, we have one LED, and this LED has 2 colors. Has the red, the green, and the blue. Okay. So if I want to generate any color, okay. So any color. So here the RGB will be called a base. So this is a base. Okay. Or a color space by using the red, the green, and the blue. Now, if I want to display any color, you have to make percentage of red, and the percentage for the green, and the percentage for the blue. And so the color here will be the red multiplied by here the probability of the red plus the green multiplied by the probability of the green plus B, which is the blue multiplied by the probability of the blue. So with the RGB represent the component of the color in red, green, and blue. So here we have, for example, XYZ. You can use with a color base, which is the color space, which is XYZ. So instead of using red, green, blue, we can use other standards, like for example, 3 primary color. Okay. So here generally in computer we are using the RGB. In printer, for example, we have the CYMK. Okay, so the C is the cyan, M is for magenta, Y is for the yellow. So this is our base, and we can add also the black if you want to print something in black color. So in black, if you combine the 3 colors together, if you combine the cyan with the magenta with the yellow, if you add the 3 colors together, you will find the black. In computer, in the screen, if you combine the red with the green with the blue, if you make full of red, full of green, full of blue, you will find the white color. So here the background here is white. That means the LEDs, they are working as red, green, and blue at the same time. Okay. Now, to select the color, we can use now void set color. You can use the color C, or you can create the own color. So how can I create a color? By giving here the red component, the green component, and the blue component. And here you can use an integer. If it is an integer, so the value is between 0 and 255. Okay, we can also use a float. And if you have float, that means the value will be from 0 to 1. 0, and there is no color. 1, and you have a maximum of the color. Let's try this. Now, in the previous example, here we have G2, but set color. Now, let's create our own color. Let's create a new color. New color. And then we have to give the values of this color. Okay. So here we have to give the red component as integer. We have to give the green component, and we have to find the blue component. Now, if I make, for example, for the red, let's make it 200. For the green, let's make it 150. For the blue, let's make it 15. Now we created one color. Now if I run, you can see that we are using this color. So it is this color. So here we use 200 for the red, 150 for the green, and 50 for the blue. So here the base that we are using is red, green, blue. So the first value here is the red, the second value is the green, and the third value is the blue. If I need pure red, how can I do it? So for every color here, for every color, for example, for the red, you can have here a range from 0 to 255. 0 means there is no color, and 255 yani full color for the red. And if I give here 255 for the red, then you have the maximum of red. So if I need the pure red, what is the value of the color? For the red, I have to make 255. For the green, what should be the value? I need pure red, and without any other color. For the green, what should be the value? If you want to draw something in red, do you have to use green? No. So we can make 0 for the green and 0 for the blue. So this will make pure red. And try this. We can make 255 for the red. We can make 0 for the green. We can make 0 for the blue. So here you can see that we are using the red. If I need the green, we can make 0 for the red. We can make the max 255 for the green and 0 for the blue. This is the green. If I need the blue, so I can make 255 for the blue and 0 for the green. So we will have the blue color. Now, if I want to mix, for example, green and blue, so let's make 255 for the green, 255 for the blue. Now I'm having a color between the green and the blue. I mix now the red, 255 for the red, 255 for the green, and 0 for the blue. You can see that now we have the yellow color. You can change the ratio. You can make, for example, you just 150 of green and maximum of red. You will find this one. You can add some blue. You can find this one, etc. So any color that you are displaying here, it is the composition of red, green, and blue. You can also use a float. You can make here, for example, if I need 1, the maximum will be 1. Okay, and 0, and there is no color. Let's make here 0.1 F, and let's make here green. Let's make 0.9 float for the green, and let's make it 0.5 F for the blue. Now you can see that you have another color. And here the dominant color will be the green. We can add also the transparency. Let's return back here for the red. Let's make it 255 red. And then let's make 0 green, 0 blue. And now I will add another parameter, which is the transparency. So here we can add another integer here, which is A, and this A is for the transparency. So the transparency, also if you are using integer, the transparency can be between 0 and 1 if it is float, and between 0 and 255. 255, yani we have full transparency. 0, yani there is no transparency. Let's try this to understand. So here the color will be full for the red, 0 green, 0 blue, and let's make transparency of 255, maximum transparency. Now we have the pure red. Now if I reduce the transparency, let's make it 100. You see that now we are reducing the transparency. Okay, so if you have an object behind it, behind this object, you can see the object that is behind it, because we will reduce the transparency. That's why at the end of this lecture, you will see how to deal with many images, one behind another image, which one will be the first plane, which object will be in the second plane, etc. Okay, so by modifying the values of the transparency, we can change the order of the objects. So here I have an example. Here we are creating 3 circles. We are creating this circle, we are creating this circle, and this circle. The first circle is red, then we have blue, and then we are creating the intersection, and we are filling this intersection with a color, this intersection with another color, this intersection with another color, and then we are filling the intersection of the 3 circles with another color. Now, for the intersection of the 3 colors, it is in white. So you can see that here for this area, which is RGB. So here, first of all, what we have 3 ellipses or 3 circles, are red circle, green circle, and blue circle. And then we are creating some areas from these circles, and then we are taking the intersection. Here we have red, green intersection, and then you have the green-blue intersection, and the blue-red intersection, and we are creating an area for every intersection. Okay, and here at the end you are filling the different area. Okay, we are filling here by the color, by the red. So here we don't have red, we have 255. So G2.set color, so we are selecting the color here, 255 for red, 0 for green, 0 for blue, and we are filling the R. So this would fill the first circle in red. Then you are changing the color to make it 255 for the green and 0 for the red, 0 for the blue. You are filling with the green area. And then we are selecting the blue, we are filling the blue area, etc. And then here we are using the red and the green. And you are filling here the red-green area, which is this, etc. So here we write this quickly. Can you repeat, please? Opacity, no bubbles. Transparency. So if you make transparency of 0, you can see that we cannot see anything. If you make full transparency to 55, you can see that we will see the full color. Okay. Okay, so here, let's continue. Here, the red is not defined, but you can make 255 for the red, 255 for the green, 255 for the blue, 255 red, 255 green. So here we are using red and green. Here we are using green and blue. So 255 for the green, 255 for the blue. Here we are using red and blue. 255 for red, 255 for the blue. And here we have 255, 255, and 255. So maximum of red, maximum of green, maximum of blue will give us the white color. If you use 0, 0, 0, it will be the black color. Now we can run. You can see that. Okay, so here there is a problem. Let's remove the color that we have at the beginning. No, it should be 255. That's it. Find the red. Okay, so now we can see the first circle in red, the second circle in green, and the next circle in blue. And then we have the intersection between the red and the green, which is the yellow. Then we have the intersection between the red and blue. Then we have the intersection between green and blue. And finally, the inner area is the intersection of the 3 colors and the three colors will give us the white color. Any question about this? So if I need the intersection of the three, if I change the intersection of the three colors, I make it 0, 0, 0. So 0, 0, 0, and there is no red, no green, no blue, so it is the black color. So instead of white, we will find the black. Okay, so now we have done the colors. Now let's see how to fill any shape. So I've seen that you can fill a shape by using the color. Okay, and we'll see also how to fill shape with the gradient paint and how to fill shape with the texture paints. Okay, now what does it mean here? The gradient paint. The gradient paint here, that means we are mixing two colors. Let's suppose that we have a shape, and I want to fill the shape with the gradient. So here I need, for example, the blue, and here I need the green. Okay, and here I want to see here a variation or a gradient from the blue to the green. Okay, so to do this, we have to define 2 points of the gradient. We have to give the color of the first point, and we have to give the color of the second point, and then we can apply the gradient. Okay, and the gradient can be cyclic or acyclic. When it means cyclic, that means we are repeating the same fashion, okay, or the same sequence of colors, you are repeating them, okay? And if it is acyclic, and we will use from the blue to the green, and then we will not repeat the same shape, okay? So how to do it? So with the gradient paint, so how to do float x1, y1. So these are the coordinates of the first point. So we have p1, which is the first point, and then we have to give the color of the first point. Then we have to give now the second point, Q2. We have to give the x and y of the second point. So we give the first point, xy, and then the color. And then the second point, xy, and then the color 2. And then we can apply this gradient paint. Now we have another option. So we can use here we can add the Boolean value, which is the cyclic or acyclic. So the Boolean value can be true or false. So here we can make gradient paint on the first point as the first point, then the color of the first point, then the second point, and then the color of the second point, and then here the cyclic, it will be true or false. So let's see this example. We have here a rectangle. We are creating a rectangle here from the point 10, 10. And here we have the width of 200, and you have a height of 200. And you want to fill this rectangle by using the gradient paint. So you have to define the gradient paint. So how to define the gradient paint? So the gradient paint, we can be doing here. It is new gradient paint. And then we have to give the coordinate of 2 points. So here we have the first point at the coordinate 200, 200, and it is red. So the first point here is in this area. This is P1, and it is red. And then we have another point, which is 200, 150. 200 for the x, 150 is here. And the value here is green. So I have this point, P1 is red, this point, P2 is green, and then you can see that I have the gradient here between the different 2 points, and here we are repeating the same gradient. Okay, so here, because we are making here comma true, and it is a cyclic gradient. Okay. Okay, so this is our gradient paint, and this is our rectangle. Okay, can run. You can see that here we have a cyclic gradient paint. Okay, now we can change the colors. We can make, for example, from the blue to the green. Okay, So you can see that now we have a gradient band from the blue to the green. So we have here we have the first point, blue, the second point green, then blue, then green, etc. It is a cyclic gradient. If we make it acyclic, or to make here this true, to make it false, so we change it to false. That means now it is not cyclic. So we make the gradient just one time without repeating it. So start from P1, which is green, or which is blue. In this example, P1 is blue. Start from P1. This is P2. P2 is green. We continue with the green. Now, if I change P2 here, for example, see what is the effect of doing this. Let's now change P2. Instead of making 200, 150, we can make it 200, and then here we can make it as 10. Now you can see that we have another matrix. So in this example, we have P1. This is P1, and here we have P2. So P1 is blue, P2 is blue. Now, if we select other points, let's suppose that now I select a point, P1 here and P2 here. P1 here and P2 here. So let's try to do this. Let's change the position of P1 and P2. Now let's make P1 as for the X component, let's make it 10. For the Y component, let's make it invalid 20, for example. And here, instead of 10, let's use 50 and 20 for the Y component. And let's make it here as cyclic. Through. You can see that now we have a variation, which means you can see that we have now vertical bars of color from P1 till P2. Is this clear? If I want to make the variation over the diagonal, we can use, for example, here 10, 10 for the first point. And for the second point, let's make it 100 from 100. So here we will see variation over the diagonal. If we make it as acyclic, so false here, you can see that we are not repeating the same pattern. We start from the blue till the green, and then we continue with the okay. Any question about this? Okay, so here in this example, we have and then you can see that we have horizontal colors. Here we have the vertical colors, and here we have the diagonal colors. So here we are diagonal gradient. Here we are changing just the position of the points. Here 10, 10, 50, 10. Here we have 10, 10, 200, 200, and here we have sorry, the gradient points. Here we have okay, the first point is 200, 200. The second point is 200, 100. Any question about this? Now we have seen how to fill an area with a color, solid color. We have seen how to fill an area with a gradient. Now we'll see how to fill a shape or an area with an image or with a texture. So filling an image with a texture. So to fill an image with a texture, for example, let's suppose that we have a rectangle and we want to fill a rectangle with the texture of bricks. And with the texture here of bricks. So I will not draw all the bricks like this, but you can select, for example, an image like this with for example, 3 or 5 bricks like this, and I can use this image as a texture. So I have to repeat the same pattern. So the same pattern here will be repeated for the whole area. Okay, that's why here for designing or for creating texture paint, you have to give an image. And we have seen in the previous class how to import an image by using the buffer image class. And then I have to give the rectangle anchor, the rectangle which is the rectangle of this image. How we are applying this image. So to find or to give a rectangle, you have to give this point, the one, and you have to give the width, and you have to give the height. Okay, once we defined the texture paint by giving here the image and the rectangle, we can apply this texture paint. So here we have an example. So here we are making the turtle by drawing some ellipses. So here we have the first ellipse, we have an ellipse here, we have an ellipse here, we have another ellipse here, we have another ellipse here, and we have a big ellipse for the body. So here we have right, left. So here we have the right arm, leg, or left, or right leg, and the left leg. And then here we have the body. So the last one here will be one. So here you can see that we are applying an image to fill this ellipse, which is the body. Okay, so how can we do this? We can use the buffered image class. We absolutely use this class. We have to use the try catch. Okay, and then we have to create a buffered image. So buffered image will equals null at the beginning and use the try. Then here we have to use image input output dot read, and then we have to give here the path of the image. So here we are using the tissue, which is this image here. Okay, this is the tissue. We are using picture like this. Okay, I don't have the same images in my computer, but we use other images. Okay, and then we are filling these arms and these legs by using this texture. So this will give us this out. Okay, and then we are loading another image. Now we are using image of turtle. So here we have the turtle.jpg, and then we are applying this paint. How to apply the paint? We have to use g2.setPaint, and here we have to give the image. So here we have new texture paint. We have to give the image, and we have to give the rectangle. So for the rectangle, here we are using the rectangle pd.double. This is the upper left corner, and here we have the dimension of the rectangle. So you can see that here we are using small rectangle for creating the texture. Okay. Now for the turtle, for the big turtle here, or for the body, we are using this image, and we are using here rectangle. You can see that the dimension of the rectangle here is bigger, so we have 100 by 2. Okay, so let's try this. Okay, so in my computer, I have as a texture here excel.jpg. Yeah. And for the turtle, I have file in the turtle. So let's open the files. So texture.jpg is this texture. This is the image. And I have turtle.jpg, which is this one. So we can use this one. We can also use turtle2, which is this one. Okay. Now let's use the first turtle. You have turtle.jpg and texture.jpg. So you can see that now we are filling these ellipses by using the first image, and we are filling the body by using the second image. I can change here the dimension for the turtle. We can make it bigger. We can make it as 200 by 400 to see the effect. Okay, I can use the second image, which is 32. Okay, so you can see that here we are using big image. I can reduce the size. Let's make it 100. You can see that now we are applying this image twice for the question. So here for the body, you can fill the body with an image, with a texture paint, and here we are using a texture. We can fill the body with a color. Let's use here color. Solid color. Let's make it here component 255 for the red, 200 for the blue, for the green, and let's make it 122 for the blue. We can try this. So we are using now solid color. We can also use a gradient paint to fill the body. So we can move and then we can use the gradient paint. The first point will be 200, 200, and the color will be red and green. And the second color will be at the position 200, 400, and you are using just the red color. You can see that you have a grid. Any question about this? Yes. Yeah. Now we go to the next part, and here we are talking about the exterior properties. So if I have any shape, so I have seen how to fill this shape. The interior, we have seen how to fill the interior. We have done with the interior. Now we see the exterior part. So for the exterior part, we are talking about the strokes. Okay, so how to make this line? So to make a line here, we are not just using one pixel line. So to make a line, generally we are using here a set of pixels. Okay, so if you want to use a line, you can define the width of this line. Okay, and you can have also many options for the line. You can have the width, you can have the dash, or the dash style. You can make a line like this, solid line. You can make it like this. You can make it like this. You can make dash dot. So here we can give the dash style. And also we can have the cap shape. So for the cap shape, for the line, it can be like this. So the first point here, the second point here. Okay, we can have an ending or a cap like this, which is a round cap. Okay, you can have here a rectangle cap. If we suppose that the 2 points are here, we have here the rectangle cap. And also if you have, for example, intersection of two lines like this. Okay, so there are many options. You can have intersection like this. You can have intersection like this. Okay, so here we are talking about the join. Here we are talking about the end, or we call this the cap shape. So I have many options for the cap. We have many options for the join. Okay, and here we can get the width of the line. Okay, and we see also how to create these types of dash line. So here are some examples of intersections of line. So you can see here the intersection here. And here you can see we have a round cap, we have a square cap, etc. Okay. Now, how to create stroke? So Java 2D include the entity stroke to represent the stroke. So basic stroke provide the setting for the width, the style, the join style, and the dash style. So we can create just the basic stroke. This is the first constructor. We can use a stroke by giving only the width. We can give a stroke by giving the width and the type of the cap, the type of the join. And then we can give here a stroke by giving the width, the cap, the join, and the meter limit. We sort the meter limit. And we can also use basic stroke by giving the width, the cap, the join, the meter limit. And then we can add here one array describing the width. So let's suppose that we want line like this. So we can create an array by giving the length of the point or the length of this part, then the length of this space. So we can do this by using an array. And then we can give the phase, the dash phase, and we'll see what is the dash phase. Let's start now with the ending. So with the ending, we call this ending cap. So we'll have three types of ending. We have here the butt cap, here we have the round cap, and here we have the square. But for the connection, for the join of two lines, we can use the join bevel. This is join bevel. So you can see that it is like this. Here we have join method. And here we have the join round. So three types of cap, three types of join. And for the dash style, here is define the style of the pattern of opaque and transparent section. We can have it opaque, then transparent, then opaque, then transparent, then opaque, then transparent. So we can give here an array describing the dash style. So the dash style is described by giving an array or and the dash phase. So the dash array defines the dash pattern. Okay. So how to create this array? So the first element will represent the first dash, and the second element number one will represent the first space, and so on. Okay. The dash phase is an offset into the dash pattern, and it is also specified in user coordinate unit. So let's suppose that I want to create a line. Okay, so here I have an example of dash. Let's study this example one by one, step by step. Let's start with the stroke. And let's try this stroke in by drawing a line. Understand how it. Stroke, you can use any name here because no basic stroke. So here we are giving the width and make it as cap. And then we are indicating the cap, which is cap but here, and we are using here the join, which is join B. Okay, now we can draw a line, G2 dot draw line. Let's make it horizontal line from 100 till 400. Now we will draw this line by using this stroke. So we have a stroke of 10 as width. Let's make it 200 as width. So you can see that we have a width of 200. Now we are using cap but instead of cap but we can use cap round, for example. And let's make it as 100. So you can see that here we have the round cap. Okay, now we can change also the join, but you have just one line. We want just to understand how this works. So you can change the width, you can change the ending of the cap, and you can change the join. Okay. So to understand the join, you can use, for example, here another line, G2.draw line. Let's make it from 400, 100. So let's use now, for example, 200 to understand the join. So now you can see that we have 100 as a weight. We are using the round cap, and here we have the join, which is join B. Okay, let's use here join. Let's change the join. Let's make it join method, for example. Okay, now check this for. Now let's use the join meter. We have to change the cap. We can put it as square. understand the difference. So here you have a joint meeting. Okay, you can have a joint leader. Okay, so I have many options. You can have here join for example. And stops working, but here you have many options for the join, you have many options for the capital. Okay, so this is for the stock. Any question before going to the next part? So in the next part here we will add an array, and this array will give us the dash style. Okay, so let's see the example that we have here. So here we are creating an array, floats dash array, and here we are giving 60, then 20, then 20, then 40. So what is this array? So we are creating a dash line, so we'll not make solid line. Okay, we'll make here dashed line. Here the first value will be the opaque part. We'll make a 60 pixel of opaque part. So this is 60. And then I need 20 of blank space. So here I will make 20 blank space. And then again we have 20 of line. So this is 20 of opaque line. And so this will make this situation of 60 line, then have 20 blank, then have 40 or 20 of line, and then here we have 40 of blank. And the phase here, we can indicate also the phase. So if we start with phase 0, we start from this point. If we start, for example, with phase 20, that means I will not start from this point, but I can start from this point. If we make a phase of 30, we start from here. If we make a phase of 60, we start from here. Okay? So let's try this on the line that we already created. Shabab, can you hear me? I think there is a problem. Can you hear me?
Yes, we can hear you.
Let's change or let's add array. So I will add the array and I will add the phase. And then I will apply them, okay? So float dash array, so the name is dash array, and here I'm giving 60 of opaque, then 20 of space, then 20 opaque, and then 40 of space. And here we are using the dash phase equals to 0, okay? So here I have to add these options. So here I have to make the meter as 0. And let's use now this array, the dash array, and then let's use the dash phase. Dash array, and then the dash. So what is the value of the dash phase? Here we use it 0. So it's 0, comma 0. And let's make just one line to understand. And let's make it a long line. So what we did here, we came to the line, and here it is the dashed line. So what do we have in this line? We selected here from the array, we selected here 60 pixel, then we have 20 of blank space, and then let's see what this return. Remember what we did. So 60, 20, 20, 40. Okay, and let's see the symbol caps square. Let's use cap buttons. Okay. 60. Then here you have 20 of blank, then you have 20, and then you have 40. I want to make, for example, here, I start. And here I started with a face of 0. Okay. Now let's suppose that I want to make here 80, then blank of 40, and I need here 60, blank of 30, and I need here, for example, 40 and a blank of 20. So just to make an array with these values, 80, 40, 60, 30, 40, 20. That's it. Okay. Okay, let's make here 80. Then we need 40. Then a path of 60. Then a space of 30. Then a path of 40. And then a space of 20. Now you can see that we have our new line. Now 80. So now, so we can insert. So here we have 80, then we have 40, then here we have 60, then we have 30, and then we have 40, and 20. And then we start again. So now the face is 0. But if you make a face of 40, and we start from this position. And the first line will not be 80, but will be 40. Okay. And change the face. Let's make the face in this example. Instead of making the face equals to 0, let's note it as 40. And we start from the middle of the first line. So you can see that now we started. So the first line now is not 80, but it is 40. You can see that here we don't have 80, but we have here 40. And then we continue. So we start from here. We have 40, then 40. So this is the first 40, then we have 40, then we have 60, etc. Once we have done, we start from the beginning. Now 80, and then 40, then 60, etc. Any question about this? So this is how to create the array of the dash style. This is very, very important. Now we have a complete example here. I'm showing everything. I have a general type here of 2 lines. This. So here we can see that you have intersecting of 2 lines. You can see here the join bevel. This is the join bevel. This is the join meter. This is the join round. And for the cap, you can see that you have butt cap, you have round, and you have square. So the square, the difference between the butt and the square, the point is here. And here there is a square point. And for the butt, the point is here. Okay. And then we have 2 examples of line. So here we have a dash of 60, 20, 20, 40. Then we start from face equals to 0. So we start with 60. Then we have 20. Then we have 20. Then we have 40. And another example in which the face is 20. So the face is 20, and we start from here. And this part here will be 40, which is 60 minus the face. And then we continue 20, 20, then 40. And then we have to return back here to 60. Then 20, etc. This is for the stroke. Any question?
Yes, doctor.
Yes, go ahead, please.
Which parameter indicate how many times the dash will be repeated?
And the same pattern will be repeated forever. Right? It depends on the length of the line. So here, you can see that here we have this line. Let's make now this line longer. So let's go to the line. Now we have draw line. So here we start from 150 till 550. We can make it here till 850. So you can see that we will repeat the same pattern, but for longer distance. Okay, so we are just defining the type of the stroke. Okay, and we will apply the stroke for a rectangle, for an oval, for everything. Okay, so we can use draw rectangle instead of draw line. Okay.
Yes, thank you.
You can use draw oval. So you see the same. So let's make now draw line. Let's draw rectangle. Let's give here the same. Let's give here from 150. Let's use here the 100, 200, 200 here. So here we have the G2 dot draw correct. Okay. So we have to G2 dot draw rectangle. So we have to draw. Now this rectangle will be drawn by using the same pattern that we already designed. You can see that here we are using the same pattern of line, the same stroke. Is clear? So if we change it here for the stroke 10, 20, then for example 40, you can see that now we have another stroke. Okay, so let's close the parentheses. Let's continue. Okay, so here we have an example in which we are creating the font, and we have seen this in the previous class. So we created a font here, which is the type is serif and it is bold. The size is 144, and then we used here the font render context, and then we created the glyph vector GB by using the create glyph vector, and then we took the shape of this glyph by taking the get outline. So here, what we did here, we converted the message Java or the text Java to a shape. So now our Java is a shape. And since we have a shape, we can fill this shape, we can draw this shape, we can fill the shape with the texture, we can fill the shape with solid color, we can use gradient paint, you can do anything since it is now a shape. Okay, so here are some examples. Here we have set paint. So we are painting a new paint. So the point 0, 0, the color is red. Then the second point is 0, 30, the color is green. And then we are filling the shape glyph. So this will fill the shape, which is the interior of the shape, by using this data. We can also create here a texture. We can also use a solid color. Okay. And then are using here color, and we are creating here an array of floats. Here we want to use dashed line. So we have 5 of opaque part and 5 pixels of space or blank part. Okay, and we are creating the stroke. So G2.get stroke. We are using now the stroke with width of 3, and we are using capbat for the cap or for the ending, and we are using here the join beaver, and here we are using this GA array, and we are using now a face of 0. And now we are drawing what we are drawing. So here in this part, you can see that we can extract from the text, we can extract or we can convert this text to shape. Once we have a shape, we can change the stroke of this shape. We can change also the interior filling by using a texture image, by using solid color, or by using a gradient. So we can test this quickly. As the library, we can make it here 300. So you can see that we are using the texture, or we are using here the variation of the colors from the green to the blue. So here we have the gradient field from the green to the blue. And we are using here a dashed line for the outline for the exterior. And we are using here 5, 5. Can use, for example, 10, 10. Can use 10, 5, can use 20, 5, and change the color of the exterior part and make it as red. We can change the colors here. We can make it, for example, here, diagonal. So it should be 30, 30. We can change the colors, for example, from the yellow to the green. So since it is a shape, we can do anything for the shape. We can draw the shape. You can make a gradient, and you can even use an image as a picture. Is this clear? Okay. Now the last part here of this class, which is a compositing group. Now, if you have many objects, then which object will be in the front and which object will be in the back? In the background. So here we are talking about compositing group. So this depends on the transparency that will be for every object. Okay, so here we are talking about the alpha value or the alpha channel. So if the alpha channel is 0, yani we will not display this object. If the transparency is 1, we will display this object. Okay, so the transparency can be any value between 0 and 1. Okay, so 1 yani complete opaqueness of the objects. Okay, and then here for the color, so we display the color multiplied by the coefficient alpha, which is the transparency. So here the color will be Fs. So here we are talking about 2 objects. One, it is called the source, and the other one is the destination. So the first object that you draw will be the source. The second object that you will draw will be the destination. Now for the source, we have here the color of the source multiplied by the alpha channel of the source, and also for the destination we have the alpha, the color power of the destination multiplied by the alpha of the destination multiplied by here a factor, and this factor can be changed from one situation to another situation. So what is the alpha here will be the alpha source multiplied by F source, and the alpha this plus the alpha destination multiplied by F destination. And what is this FD and this FS? So here we are using the factors to give many situations. So here what we call, we have the porter the fruits. Now the porter the fruits will give us the values of FS and FD for many situations. So if you want to make clear and you are not displaying anything, Fs will be 0, Fd will be 0. So here if Fs is 0, so this value will be 0, and Fd is 0, so this value will be 0, so the color will be 0, so here will not display. Okay, now if you need the source over, in that case the Fs will be 1 and the Fd will be 1 minus alpha s. If you need the destination over, so Fs will be 1 minus alpha d, and the Fd will be 1, etc. If we need destination in, we need to make Fs equals to 0 and Fd equals Fd equals to alpha s. Okay, so here we have this table. This table will give us many possibilities. Okay, so here we are talking about 2 objects. So this is the source and this is the destination. Okay, and here we are trying to find which part of the source will be displayed and which part of the destination will be displayed and which part of the intersection will be displayed. So if we need the source caller occur only, so here our alpha will be alpha s multiplied by 1 minus alpha. We need the destination only, so here we have to use alpha d multiplied by 1 minus alpha s. If we need both columns, so we need the both transparency, so alpha s multiplied by alpha d. We need neither of the colors occur, 1 minus alpha s multiplied by 1 minus alpha t. So you are using here this Porter platform. So I have to indicate just what type of rule you have to apply, and then Java will make automatically the value of s and the value of x. So here we have an example. So the destination is the rectangle and the source is the limit. So here we have an example of source point. Here we have destination point. You can see that we can see the destination over the source. Here we have the source over the destination. So it's like here in the background, we have the destination. We have the destination, which is the rectangle, and in front here, we have the source. So in this example, the front here layer will be the destination, which is the rectangle. The back layer in the background here, we have the source. So if you make source in, so the part of the source that is in the destination. So here the destination is here, will display only this part. Here we have the destination in the part of the destination that is in the intersection. Here we have the source out, here we have the destination out, etc. Okay, so now how to select one of these options? So we can select here the composite. So you can use g2.set composite, and then you can use alpha composite.source in. This will give us the situation of source in. If you need source over, you have to make it just here dot source over. So alpha g2.set composite, alpha composite dot set over, or alpha composite dot destination in, or alpha composite dot destination over, etc. So here we have an example. So if you return back to the previous example, we have seen that we drawn ellipses. And after that, we draw the body. So when you draw the body will be in the front layer. If you remember the execution of the previous program. But now we'll change this situation. So this, first of all, remember what you have. You don't give the values. What we use in here, it's short. And here we use so now you can see that first of all we draw the legs and the arms. So this is the source. And then we draw here the last part, which is the body. So you can see that now the body is in the front of the legs and in the front of the arms. Okay, but now let's see the situation now. If we add, so now we can add another line describing the type of the alpha composites. Now let's change now the alpha composites. And here we are using source method. Okay. So you can see that now we have another configuration. So here you can see that we are displaying both. We are displaying the body and you are displaying the R standard text. And here you have many options for the alpha composite. And you got source in, destination out. So here you have many options. Okay, so if we need, for example, destination, so this will be as the destination. Now here many options. So here we can see that we have destination. So here we can change it. We can use source over. This is the output of source over. And you source in, destination in, so you have many options. Any question about this? No questions? Okay, let's select.